Alright, section 1.2, exponential, scientific, and absolute value notation. Before we get started, I just want to remind you that if you have any questions that just don't get answered for whatever reason, I want you to put them right down here in the questions box. So you can say something like, question number 21, I just didn't get. Maybe Bergman didn't explain it very well, or maybe you just didn't, you were missing some background information that I assumed. So, videos are not very interactive at all. I'm just the one talking and you're the one listening and writing down. That's not interactive. So this is a space for you to write your questions. If you don't feel like Googling them or texting someone else or emailing me, which you can do, I really encourage you to do, but you also want to make sure that you write down any questions that you have that don't get answered, and we can answer them in class. Also, I want to remind you that I'm going to be throwing out some personal information. So at some point, I'm just going to throw out some random information, and I want to make sure you're listening, so you can write it down right here. That's the audio check. Check, check, 1, 2, here we go. So, exponential, scientific, and absolute value notation. I love this stuff. So, for example, we've got 8 times itself 4 times. That means that you can rewrite this as 8, yikes, in black. You can rewrite this as 8 to the 4th power. This is the exponent right here, and we call this the base. The whole thing is called a power. So the power here, rewritten in with exponents for number 2, would be x to the 3rd. Moving right along, this would be 4y to the, how many times is it multiplied by itself? 4 times. Now you can simplify this quite a bit, but we won't right now. We will later. Rename without exponents, that means this could be 3 times itself 4 times. 5x times itself 4 times. Negative 5 times itself 4 times. It's very important to use parentheses here because you want to make sure the negative gets repeated as well 4 times. Negative 5 times itself 4 times, and then that's different from 5 repeated 4 times and make it negative. 5 times 5 times 5 times 5. Here, the negative gets dropped down. It does not get repeated because it's not, the exponent does not apply to the negative. No, it only applies to the 5. And there's a big difference there. Number 8, anything to the 0 power is going to be 1. And if you don't believe me, I'll prove it to you. You could type it into a calculator. Find a calculator that does, type it into the web or web calculator, whatever calculator you want. Anything to the 0 power is equal to 1. Why that is, I can explain in class on the side if you want. Simplify. So we've got 5y times itself 2 times. 5y times 5y. And if you wanted to simplify that, that would be 25y squared. Number 10, negative 2x times itself 3 times. That would be negative 2x times negative 2x times negative 2x. 2 times 2 times 2 is 8. X to the 3rd power. And 2 of these are going to cancel out, but you still have 1 left. So because 3 is an odd number, then that means that makes this negative. If it were an even exponent, all of the negative signs would have pairs and they would all cancel out, and that would be positive. Rename 1 over 4 to the 3rd using a negative exponent. Well, if you want to cross the line, then you change the sign. It becomes 4 to the negative 3. Negative exponents mean fractions, and fractions mean negative exponents. By the way, I'm doing this, I'm not doing a whole lot of explanation as to why. I'm just reminding you of things that you've learned before, which is not great for everybody. If we talk about something, if you're like, what just happened, Bergman, then the best place for it is right here. If you don't want to Google it, or if you don't want to text a friend or email me, then you can always write it down as a question, and I'll explain it in class. Rename 10 to the negative fourth without using a negative exponent. Well, Bergman always says, cross the line, change the sign. So it's no longer 10 to the negative fourth, it's 10 to the positive fourth. Write 3 other symbols for 4 to the negative third. Well, cross the line, change the sign. It could be 1 over 4 to the negative third, which is the same thing as, 1 over 4 to the positive third. What is 4 times 4 times 4? That's a good one to memorize. It's 64. And if you wanted to, you could change 1 over 64 into a decimal. Another sneaky thing you could do is say 64 to the negative 1 power. Those are three other symbols. In general, you can say the negative exponents rule is negative exponent means fractions. Cross the line, change the sign. 14. Multiply and simplify. Well, if you have 8 to the negative third and 8 to the positive seventh, what that would look like as a fraction would be this. You got 8 times itself 7 times, and 8 times itself 3 times here at the bottom of the fraction. 3 of them would cancel out, and you'd be left with 4 up at the top. That'd be 8 to the fourth. Well, instead of writing out as a fraction, an easier thing to do would just be to add the exponents together. Negative 3 plus 7. Negative 3 plus 7 is 4, and that's a faster way to do it. In fact, that's the way you want to think about it. 7 plus negative 2 is 5. Next problem. So we're going to group these. Since there's no exponents on the parentheses, 9 times negative 2 is negative 18, and 4 plus 7 is 11. This would be 11 x's all together. 4 plus 7 is 11. Next problem. Same thing. We're going to combine the exponents. It would be x to the negative 14. The 2 negatives cancel out, and you'll have a positive 75. Next problem. Here, we're going to not try and multiply or combine the y's and the x's into one big variable, but you can multiply y to the fourth, the y's and the x's individually. 5 times negative 2 is going to be negative 10. For the x's, negative 3 plus negative 9 is negative 12, and 4 plus negative 2 is positive 2. In the next problem, you'll see we've got 4 times 15 is 60, and then the exponents on x are going to be negative 2 plus 2, which is 0, and 4 plus negative 3 is 1. So if you're going to simplify this completely, this is going to be 60 times 1. Remember, x to the 0 is going to be 1, so it's just 60. And y to the 1 you can just simply write as y, 60y. In general, you can say the rule looks like this. The product rule is if the bases are the same, and remember that's a big if, bases have got to be the same, then you can add their exponents together. That's the product rule. Next problem. So if you were to write all these out, you'd have 8 of them on the top and 5 of them on the bottom, and 5 4s would cancel out like this. they'd cancel out. 5 of them would cancel out, leaving only 3 of them. 8 minus 5 is 3. So you have 4 to the third power. Well, with fractions, you can just subtract. 4 minus negative 2, that's going to be positive 6. So the answer is 5 to the positive 6. Subtract. Negative 5 minus 9 is negative 14. This is going to be 10 to the negative 14. Eight minus negative 2, negative 8 minus negative 2. Remember, minus a negative is the same thing as adding the positive 2. So you get 9 to the negative 6. 6 minus negative 5 is the same thing as 6 plus 5, which is y to the 11th. Here we're going to cancel out the numbers first. 2 goes into 10 5 times, and then 2 minus 3 is going to be negative 1. Negative 21, this is going to be negative 2. Oh, they're a little sneaky. They moved the order, so 7 minus 10 is going to be negative 3, you sneaky textbook. 6 minus negative 3 is going to be positive 9. So in general, you can say that if the bases are the same, and that's a big if the bases are the same, then you can subtract the exponents. Alright, moving right along. Then you do exponents. So here, we've got 3 to the 7th written 7 times. That would be like writing it out like this. 3 to the 7th times itself 7 times. Good night, that's a lot of handwriting. 7 times. That would be 7 plus itself 7 times. That's like multiplication. 7 times 7 is 49. The short version is when you have a power to a power, you write it, you can multiply the exponents. So 2 times negative 7 is going to be 8 to the negative 14. Four times negative 7 is negative 28. And here, what you need to do is you need to distribute the 3 to every factor. Now notice that there's multiplication. If there were addition, if it were 2 plus x plus y, you wouldn't be able to distribute the exponent like this. But because it's multiplication, you can. This is going to be 2 to the third, x to the third, y to the third. So that means it's 8, x to the third, y to the third. Yay. Here, because there's multiplication, because it's 4 times x to the negative 2 times y to the 7th, you can distribute. You couldn't distribute if it were just addition. This is going to be 4 squared, which I'll just say is 16. 2 times negative 2 is negative 4. 7 times 2 is 14. Next problem. Here, because it's division and multiplication, you can distribute. If it were addition and subtraction, you would not be able to. Boom, boom. Oh, let's not forget the 3. There you go. Okay, so three to the negative third x to the negative 12, y to the negative 6, z to the negative 15. Now, we can do some things here because it says simplify. So, in a fraction, one way to simplify things is to change them as much as you possibly can to positive exponents. So that means this is going to be, if in a fraction, we're going to cross the line to change the sign for all of them. 3 is going to be on the bottom, 3 to the third, which we'll just say is 27. 3 times 3 times 3 is 27. X to the 12th is going to be on the bottom. Y to the negative 6, well, that's y to the positive 6 on the bottom. And z to the 15th. And that can be your answer. Okay, so you might look at this and just be tempted to automatically distribute, which you could do, but actually if you want to save a little bit of work, you can simplify what's inside the fraction first. So, inside the fraction you got 10 over 5, which is 2. To negative 4 minus 6 is negative 10. 7 minus negative 8 is positive 15. And negative 2 minus negative 3 is actually positive 1. Now let's distribute the negative 3 over all the factors that are being multiplied. Again, if there were addition, you wouldn't be able to do this, but because it's all multiplication, you can distribute. This becomes 2 to the negative third, x to the positive 30, y to the negative 45, and z to the negative 3. Turning it into a fraction, I'm going to cross the line to change the sign. So I'm going to bring this one down, I'm going to bring this one down, and this one down in order to change the sign. 2 to the third, to the positive 3, which is actually just 8. X to the 30 stays on the top, y to the positive 45, and z to the third. That is the simplest version. So in general, you can say that the power rule says power to a power is you multiply the exponents together. Scientific notation. So science teachers love math teachers when they help explain scientific notation, so we're going to do it. Scientific notation is a great way to express really large numbers or really small numbers. So I'm just going to tell you what the answer is here, and then 4.65, and then I'll explain why. Times 10 to the 1, 2, 3, 4, 5. Times 10 to the 5th power. That's the answer. Notice in scientific notation that this number is always a number between 1 and 10, and it's always times 10 to some either positive or negative number, like some integer. And if this number is positive, then you're looking at a really big number. If this number is negative, then you're looking at a really small number. And the number of places that you have to move the decimal in order to create the new number is going to be the exponent. So check this out. We have to move the decimal place 1, 2, 3 times. 3.789. Is it a big number or a small number? It's big, so that means 3 is going to be positive. That looks like a really small number, so this exponent is going to be negative. 1, 2, 3, 4. 1.45, it's a number between 1 and 10. Times 10 to the negative 4. Why negative? Because it's a small number. It's a tiny, tiny little decimal. Wow. Okay, number 37. So this is going to be a negative exponent as well. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 6.7. It's a number between 1 and 10 times the exponent is 10 because I moved it 10 places, and we make it negative to indicate that it's an incredibly small number. Next problem. Here we're going to do the opposite thing. So the first thing I look at is whether or not the exponent is positive or negative. Here, it's negative, so that means we're going to make a really small number. We have to move the decimal place 5 times, so 1, 2, 3, 4, 5. 0, 0, 0, 0. I need 4 zeros in front. 1, 2, 3, 4, 4, 6, 7. Small number, negative exponent. People sometimes ask me, hey, Bergman, what's the rule? Does it go left or does it right? Well, it's just confusing, especially depending on if you're converting between scientific or standard notation. So I just say big numbers mean positive exponents. Like in this case, this is going to be a really big number. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. You have to move the decimal place 12 times, meaning it's going to be 7, 9, 4 with 9 zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9 zeros. That's a huge number. In science, you have to work with numbers that are really huge and really small all the time. So that's why we use scientific notation. The rule here, big numbers equals positive exponents, small numbers equal negative exponents. Now this is actually scientific notation, or it's a calculator version of scientific notation. The E just represents 10 to the, in this case, 9th power. So this is going to be 8.166 times 10 to the 9th. That's all that means. 1, 2, 3, 4, 5, 6, 7, 8, 9. 8. I need 6 zeros. 1, 2, 3, 4, 5, 6. How did I know it was going to be such a big number? Because the 9 is positive. The 9 is the exponent. Here it's going to be a small number. 1, 2, 3, 4, 5, 6. I need 5 zeros. 1, 2, 3, 4, 5. 1, 1, 0, 3. This is just how calculators do it. Most calculators don't have room for the times 10 to the, so they just write an E. E represents exponents. Find scientific notation for the number of seconds in 1 year. Use 365 days for a year. Wow, okay, so what we need is 365 days in the year times 24 hours in a day times 60 times 60. When you do that, you get 315,360,000. That's how many seconds are in a year. Now, this might be our first word problem of the year, so it's worth it for me to let you know that word problems are incredibly important, and they're really great for making sure that we understand why we use math in the first place. But every time there's a word problem, what I really want you to do is get in the habit of writing down the units. Don't just write down the numbers. The units help you tell the story of what's going on in the whole word problem. And so if you don't know what the units are, then that might indicate that you don't really understand what's going on. So find the units and label them, and then therefore understand the story much better. So this is going to be 3153600. We have to convert this into scientific notation. 1, 2, 3, 4, 5, 6, 7 places. 3.1536 times 10 to the 7th power. Why is it positive 7? Because this is a really big number. compute, right, scientific notation for the answer. So here, we're going to multiply 8.3 times 7.6, and you get 63.08. And then when you combine these two, you add the exponents, times 10 to the negative 11th. Now, the only problem with this could be the answer, but actually it's not quite scientific notation yet, because the 63.08 is not numbered between 1 and 10. So what you need to do is you need to move this, or you need to say that this is 6.308 times 10 to the 1 times 10 to the negative 11. What I just did there was I took this number, 63.08, and I changed it itself into scientific notation. So then you realize that you can combine these two. 1 plus negative 11 is negative 10. 6.308 times 10 to the negative 10. So here we have 1.8 divided by 2.5, and if you do that, you get 0.72. Here, subtracting the exponents, negative 16 minus negative 7 is going to give you negative 9. Now this is not quite the scientific notation, because the 0.72 is not a number between 1 and 10. So therefore, you can rewrite 0.72 as 7.2, moving the decimal place once, times 10 to the negative 1. And then that's all, of course, times 10 to the negative 9. When you add these two together, negative 1 plus negative 9, you get negative 10. 7.2 times 10 to the negative 10. And that is your answer. Next problem. We've got, to simplify, Pemdas. Well, I think you can do this problem right here. I think you can do this. So, I'm going to do the harder one. Why don't you pause the video, and when you're finished, we'll go on to 46. Please excuse my dear Aunt Sally. I do want you to remember that multiplication and addition, you do at the same time, you just whatever comes first. First do the parentheses, exponents, multiplication and division at the same time, addition and subtraction at the same time. What that looks like is this. You've got 3 plus 2 is 5 squared minus 3 plus 2 squared plus 1, all over 2 to the third, which is 8, and 5 to the 0, which is 1. That's inside parentheses to the third power. 5 squared is 25. 25 minus 3 plus 4 plus 1 over 9 to the third power. 25 minus 3 is 22, plus 4 is 26, plus 1 is 27, divided by 9 is 3. This is 3 to the third power, or just 27. Absolute values, if there's a number inside the absolute value it's positive, you always make it positive, so this would be 2. But if negative 1.3 to the absolute value of negative 11.3 is going to be just positive 11.3. And when you're simplifying absolute values, always make it positive. Here, you can take the absolute value of things that are being multiplied, so it becomes the absolute value of 10 times the absolute value of m squared times the absolute value of n cubed. Now, the absolute value of 10 is 10. The absolute value of m squared is always going to be m squared. It's always going to be positive. So if that's true, then n to the third is going to be n squared times n. And n squared, the absolute value of n squared, is just n squared times absolute value of n. Didn't see that? I'll do it one more time over here with the next problem. This is going to be the absolute value of -2 times the absolute value of x to the third, all divided by the absolute value of y squared. Well, the absolute value of -2 is just 2. The absolute value of y squared is always just going to be y squared, because y squared will always be positive. Similarly, we can split this up into two different things. X squared times absolute value of x. So therefore, it becomes 2 times x squared times the absolute value of x. Alright, there it is. For an audio check, I want you to write down my favorite animal. And my favorite animal is ants, specifically leafcutter ants. So go ahead, write down, assuming you're still listening, then you can hear that my favorite animals is the leafcutter ants. I want you to start your homework, do the first problem. We're not going to call it homework. I'm going to start the assignment that we'll do in class. Start assignment 1B and do the first problem. We'll talk about it in class.